what these quantum communication devices do is they actually give us a way to transmit unspyable data, which is incredibly revolutionary in the security space.
Hey, Rebecca, I'm so excited to be able to chat with you today and talking more about quantum technology and what your firm is doing. To begin, can you share, Q-Secure, if you had to explain it very briefly, like 5 seconds, top line, what would you say it is you're focused on?
Q-Secure, it's security for the impending quantum revolution for enterprise and for government.
The impending quantum revolution. We are starting to hear more and more about quantum technology and the concepts around it. What do you see that specifically you're looking to then solve when it comes to security and how this will affect everything?
We hear a lot about quantum computing, and that's kind of the big kind of sexy, for lack of a better term, branch of this whole quantum technologies field. But there's a few different branches, and quantum computing is just one. Then we have quantum communications, and quantum communications is really what the basis of what we're working on involves. And then there's also quantum sensing. And so these are 3 distinct technologies, and I just want to make that clarification. They're all interrelated because they all leverage these quantum physical properties. You have these boxes, say, and imagine you have box A and it's sitting in San Francisco, and you've got box B and it's sitting in San Jose. And each of these boxes has a few qubits, right? And qubits are sort of the quantum analog to your classical bits on computers. And what these boxes do, they do 2 things, 2 really cool things. One is they generate genuinely random numbers. And this is important in cybersecurity. This is, random numbers are used, are pretty fundamental to a lot of cybersecurity. But the problem with random numbers as we generate them today typically is that they're pseudo-random. They're algorithmically generated. So you can actually, if you try hard enough, if you're a bad actor and you try hard enough, you can actually figure out what these numbers are, and then they're insecure keys. So using these quantum communications devices, the first thing that they do is they generate genuinely random numbers. And then the even cooler thing that they can do, the second thing is, so they leverage this property of entanglement, which is one of those weird quantum properties. And you can, if you've got your box in San Jose, you got your box in San Francisco, you can actually transmit this random number, this key we're going to use, from point A to point B via entanglement. So not via any classical route that we sort of imagine, but actually sort of behaving as one entity. And also because of the strangeness of quantum physics, if you try to intercept this key, so say you're trying to man-in-the-middle attack this, you're trying to spy on and crack the secrets of a company or whatever you're trying to do, it actually interferes with this system in a way that tells you, hey, there's somebody looking at this. And then once it gets to the side that you're trying to send this key to, you know that there's someone that's tried to spy on this. So it's what these quantum communication devices do is they actually give us a way to transmit unspyable data, which is incredibly revolutionary in the security space.
Now, you've already got this in play. You've got multiple contracts that are utilizing this. Can you tell me more about maybe a use case in this in play?
Absolutely. Yeah. So our first major customers are within government. So Air Force, Army Futures Command, Pentagon. So these are organizations that are very concerned, right, about protecting their data and their communications. So so they're very interested in this kind of thing. And the likely reason that we started with government is because when it comes to, so the other side, I guess we started with quantum communications, right? But now I'll tell you where the quantum computing comes into play. So there's something called Shor's algorithm, which is it's an algorithm specifically designed for quantum computers, and it basically says at a certain point, quantum computers can break the vast majority of our standard forms of our standard cryptography, so RSA, etc. So when it comes to quantum investment, there are other countries, including China, Russia, who have put billions and billions of dollars into R&D in quantum computing. And so from a national security level, the US are very concerned that at a certain point, we will not be able to protect our data in the same way that we have been, because these other nations have advanced technology that can crack that. So, so the reason that we're working in government right now is that, yes, they're very interested in using these quantum communications, this quantum communication infrastructure. On top of, there's a new form of cryptography that we're also using that is quantum secure. So it's a few different layers of things that will help, protect these really secure communications, these really secure data transmissions, whatever they're working on, so that we can ensure that no external sources are spying and getting information that they should not.
Your business model is to help install these systems and help monitor it. Tell me more about your business model.
Probably the best thing about what we do is, while it sounds like you might need a complete overhaul of your infrastructure, it's just a layer that sits on top. So while we primarily work with government right now, we are expanding quickly to enterprise. So we have some strategic investors and companies in the financial sector, as well as in the, like internet infrastructure sector. And so what we are is we are that layer that sits on top of what exists already and just secures it even more. So we have hardware components, obviously the quantum communications devices, but these are surprisingly integratable, implementable, and affordable for enterprise. And then we have that software layer that also sits on top and protects any existing infrastructure.
Can you tell me more about the hardware? Have you guys developed it? Is there kind of like a standard being created around that?
Yeah, absolutely. So there are a few different companies that we partner with. We don't do the hardware, we're the software people. And our primary partner is Toshiba. And so they've developed really, really strong technology around these quantum communications boxes. So you would probably put these boxes in your typical rack, and then transmit between your data centers or whatever it might look like. But yeah, so we work primarily with Toshiba, but there's a few different companies that have really strong technology.
And on something we were talking about before, and you mentioned to it, like there's elements of then the quantum technologies being used, this entanglement, which is awesome, but you're using more practical concepts right now and scaling up where needed. Can you tell me a bit more about how that technology works and how you've implemented it, and how it's different from what somebody's maybe already using right now?
When you transmit any kind of data, any kind of sensitive data, it's encrypted, right? Typically RSA, AES, any kind of these standard things that are supposed to make data unreadable by anyone who's not supposed to read it. And you decrypt it on the end where you're supposed to receive it, and there you go, you can see your data again. So that is now vulnerable. And in the next several years, it's going to become obsolete because quantum computers are approaching that level where they can just slice through these like butter. So that's not a good thing, right? Encryption, privacy, very important, especially in sectors where you're dealing with really private or really sensitive data. And we've already seen a lot of these data breaches in the last, like, high profile ones, right? There's a term that Jack Hatery, who heads up quantum and AI at Alphabet X, and he's coined the term SNDL, store now, decrypt later. And that's actually a typical way that that hackers will take data. Even if they don't have the capability to crack it right now, they will grab an encrypted data set or whatever it is, and they'll sit on it for a few years until they have the computing power to actually cut through it and then sell that data on the dark web or whatever vector they want to sell it on. And so that's actually how we've seen a lot of these recent high profile hacks come out. Is they were encrypted, these guys got access to GPU farms or whatever it was, and boom, they've got their data a few years later.
For those that in the enterprise sector that might be interested in learning more, where should they go, and what's a good first step for them to take with you guys?
Absolutely. I think, we check out our website. It's a good first step. Reach out. We're always happy to talk, demo. Because we are fully designed to be a layer on top of existing systems, we can integrate in a lot of places. It's not necessarily for every company, but we are always happy to chat with anyone who's interested, inform, and see if it might be a good fit.
Have you seen a company using AI, machine learning, or other technology to transform the way we live, work, and do business? Go to uptechreport.com and let us know.